All right, so this is page 592, the review section, chapter 10 here. I'm going to go over number 3. It says find the area of this parallelogram. I drew it down here. It is a parallelogram, so it is base times height. Now you got to pay attention to the fact that base and height does not mean side times side. Don't make that mistake for a parallelogram. You have to have a base and height that is 90 degrees with each other. So if I look at this picture that I redrew here, it's 8 here at top, there's 8 here on the bottom, 9 here on the right, 9 here on the left. Now 8 and 9 are not base and height. This is not 90 degrees, and if it's not 90 degrees like a rectangle, don't say 8 times 9 is the area. But what is 90 degrees is down here. And so this red line is the height. It is the height with side length 8. And what we need to do is just focus in on this triangle here to help figure out this h height. Because if I can figure out that h, I can just multiply it by 8, and that's base times height. This is 60 degrees. This is 9. And so we have a trig problem. I'll stand at 60 degrees. I'll say sine of 60 degrees is equal to opposite height over hypotenuse 9. If I go to the calculator, the height of this figure is 7.8. So from the top to the bottom, it's 7.8. And then to figure out the area here, you just go base, the base is 8, times the height, which we just calculated, 7.8. And this area will end up being in the calculator, 62.4 meters squared. All right, I'm cleaning up the paper. Let's move down to number 5 here. Find the area of the regular polygon. Number 5, it is a hexagon, meaning a 6-sided figure. They actually just give us, it's kind of hard to see in the picture, but they actually just give us this number here, which is the radius when you go from the center to the corner. That is a radius of 4, and they want you to figure out the area. So the formula for area of any type of regular figure is 1/2 apothem times perimeter. Well, we don't have the apothem, so first of all, we're going to draw that, and we're going to figure out what that A is. That would be the apothem, nor do we have the side length, and so we're going to put an X here, and 2 X's would make a side length. We're going to have to figure out both A, apothem, and X. We obviously going to use the number 4, but we're going to need more than just the number 4. We're going to need angle degrees. So a 6-sided figure, I'm drawing all 6, what do we call radius, to each of the corners. 360 divided by 6 is 60 degrees. That's each one of these angles is 60 degrees. And then one angle is split. The 160 degrees angle is split. And what I'm going to do is enlarge this one particular triangle here in yellow, because this is the one I want to focus in on. And this is now, instead of 60 degrees, it's now 30 degrees here. This is still 4. This is A for the apothem. This is X, and we want to figure out X to help figure out the perimeter. So we're going to use sine, cosine, tangents to help figure out the apothem and X. So let's set up for the apothem. If I stand at 30 degrees, I'm going to say cosine of 30 degrees means adjacent apothem over hypotenuse 4. Go to the calculator and crunch this out, and the apothem will be 3.46. Now we still need to figure out this X down here, because that will help figure out the perimeter. So we're going to say, go back to the 30 degrees, and we'll say sine of 30 degrees is equal to opposite X over the hypotenuse 4. Crunch it out in the calculator, it's 2. And then of course, that means if this is 2, this is 2, 2 plus 2 is 4. That means each one of these sides is 4. Okay. So let's go to the actual formula here. Area is 1/2 apothem. Apothem is 3.46 times the perimeter. We know each side is 4. We know there are 6 sides to this figure, so we'll go 4 times 6. The area, once we throw all of this in the calculator, is 41.5. And I believe that's feet squared. I can't even see this book because somebody wrote in it and it's destroyed now.